Hi, my name is Mike Shane, and I'm a research scientist and the Director of Fisheries Replenishment Operations for our Sustainable Seafood Program here at Hubbs-SeaWorld Research Institute. Starting in 2010, we introduced an education program called Seabass in the Classroom. This education program was created by us at Hubbs-SeaWorld Research Institute, and it's operated in partnership with Get Inspired and the California Department of Fish and Wildlife. This program is made possible, obviously, by generous support from organizations such as From My Heart Charitable Fund, San Diego Gas and Electric, Chevron, Southern California Edison, and many others. Through this hands-on classroom program, students are learning about aquaculture and replenishing our oceans by growing white sea bass in their classrooms. These systems are saltwater and they're closed, meaning that there's no fresh saltwater input. So with these closed systems, there's various life support components that are essential to make these program or the students successful at growing fish in their classrooms. Obviously, the system includes a tank. There's a chiller to help control the temperature. There's a sump, and in this sump, the water from the tank flows into the sump where there's media or particles in there that help the nitrifying bacteria grow on, and the nitrifying bacteria help break down the waste materials that are toxic to the fish, that are excreted by the fish, that are to make them less toxic. Important activities of the Sea Bass in the Classroom education program include the S for science, in that the students are learning about science through measuring and weighing and tagging their fish, and they yet to actually, as part of this process, are seeing the use of anesthetic to help put the fish to sleep, to make it easier for them to handle and safer to remove them from the water. They're also learning about water chemistry by taking daily water chemistry measurements and learning analytical practices of science. The technology that they're learning, or the engineering, so the T and the E in STEM, are the components that I explained a little bit earlier about, that the systems are built upon. And so they get to see that technology, they get to see how it's engineered and put together, how it works, how the water flows through there. As part of this program, the students also get, and the schools that are participating here, get to come to the hatchery and tour our marine fish hatchery here on the west coast of the United States, which is the only one that is currently built for marine finfish and for our larger scale fish replenishment program for white sea bass. And then M, or the math part of STEM, the students are actually learning to use and calculate food conversion efficiency. That is, how much food is put in that they're feeding their fish and how much growth that is occurring in the fish. So they can understand if they're adding too much food, too little food, by calculating food conversion efficiencies. They can work on looking at water exchange and turnover rates. They can do calculations there. They can actually do the math to understand growth rates, how fast their fish are growing. One unique aspect of this program is it also helps with collaboration amongst other classroom or school-based programs, such as maybe the math department or the computer design or CAD program department at their schools, and they can collaborate and interchange with ideas and troubleshoot problems and solve. For example, they can work with the math department and have worked with students from the math department to understand their water turnover rates and do the calculations for that. They can also work with their students that are in the computer design or CAD software programming part of their school, where they can design and build and have done media that would go into the sump, and then they use a 3D printer to then print out this media and kind of test and see what's the most effective media for the nitrifying bacteria. At the end of the semester, or near the end of the semester, the students actually, we come back to the classroom. The students get to tag their fish in the classroom, so we have the technology there brought into the classroom. Each student gets to implant a small stainless steel coated wire tag into the cheek muscle of every fish in their classroom. And then at the end of the school year, they release their fish into the ocean, thereby becoming stewards of the environment and being sustainably and socially responsible for this program, as part of this program, and becoming stewards again of the environment.
Hi, my name's Greg Gardner. This is Edison High School, the Huntington Beach Union High School District in Huntington Beach, California. This is our Seabass system that our students are currently using. It's part of our innovation lab. We've taken a auto shop and we've converted it into a large aquaculture center. We're also doing aquaponics and hydroponics. But with what we're doing with the STIC program, the Seabass in the classroom, is we're teaching students how to use and see the applicability of this system and how we can actually raise white sea bass in the classroom. Learning about the different equipment types, learning about food and the distribution of the species, and how we as humans are impacting our environment, and how we are changing our environment by actually adding these into our coastal systems. And it's a great learning experience for all of our students. Our students are getting a lot out of it, and it's a great program. We're trying next year to put a camera in here so we can actually see it, see the fish actually swimming, and look at what their behavior is in their interactions. We tried it this year, but the camera that we got just got too bad. Anyway, the point is, we're about trying to make learning exciting and fun, but bringing it with our current conditions now to them at home through this process. Thank you.
All right, Greg, so you have a lot of other things going on in the lab here. What else do you have going on?
Well, we have a large 500-gallon coral tank system that our students have built here at Edison. We're trying to look at how can we do coral thriving and how we can actually be sustainable. We can't put the corals out onto our ocean reef area in where they come from in southeast in the South Pacific. But what we're trying to do is to propagate and actually look at how we can get these corals as a learning environment for our students. And it's just a great opportunity for them to learn and see the coastal interactions of why coral reefs are so important to our ecosystems. And they have a bunch of variety of species of coral and a lot of fish. We also even have a camera system, and we're also that we can actually see on YouTube, where you can actually see how the fish are interacting with the coral in the tank. It's a way cool, it's exciting, it's fun, and it's a great learning experience.
Hi there, I'm Steve Walters from Mission Bay High School, and I'm here to talk about the Seabass in the classroom. We've been associated with Hubbs-SeaWorld since 2014, so we've let go a lot of fish. The students that I teach IB Marine Science and Advanced Placement Environmental Studies, they work in here. There's various activities going on, but this is the key to this whole lab in here. It's the white sea bass. So every day we have about anywhere from 4 to 10 students come inside here, check on the sea bass, feed them, clean the tanks, monitor the chemistry of the water, check that temperature. And the kids take a lot of pride in this, and when we do release them, they like all gathering at the beach and watching the little guys swim out in our bay. It's really a great part of my marine science program for sustainability, and actually they're actually doing something to put fish back into the ocean. And outside of that, I wouldn't mind having another tank since Mike's filming, but that's another story. So great program. I wish you could get out to more schools. It would be really cool if we had more schools in St. East and in Southern California in general. But I'd like to thank the people at Hubbs-SeaWorld for all their efforts, and especially Mike Shane for every year hounding us to get those fish back in the ocean. So thank you very much.
My name is Sabrina Mashburn, and I am the new education coordinator here at the Hubbs-SeaWorld Research Institute. I am so excited to be here. I've been working on a few new projects for the upcoming school year, all of which are going to make our program bigger and better, and hopefully serve our teachers and students even better than before. The first of those is a dedicated Seabass in the Classroom website, where all of the students can go along with their teachers and access data, input their fish's measurements, and also learn more about white sea bass aquaculture and where they can go with their aquaculture education after they have graduated from high school. One of our projects that I'm really excited about is a series of short video clips that will be taken at the hatchery to bring the hatchery experience home to the students who cannot come to our hatchery, and also into their classrooms so they can see how the fish that they're raising are related to this greater project that is helping to replenish white sea bass in the wild.